Making Data Simple, where we make the world of data effortless, relevant, and yes, even fun.
In this episode, we're taking a chance to present clips from some of my favorite conversations of 2018, from data visualization to the Internet of Things to data learning. 2018 was full of incredible conversations. It's like my children, I love them all, but I feel like I've learned a lot, and I hope you have too. I'm going to jump right in. One of my favorite conversations of the year was with Lisa Seacat DeLuca, an IBM Distinguished Engineer and Master Inventor. These days, she works on IoT, Internet of Things, and I asked her to unpack some of the terminology.
Do you see any distinction between IoT and the edge, or is that one and the same, or is there a definition distinction between the two?
There's definitely a distinction. I think edge is more about knowing that you're in a situation where you can't necessarily have access or send your data to the cloud quite fast enough to where you can make insights quick enough. So it's like maybe the network is not as strong, or you're in a dead spot. I mean, I grew up in Montana, so there's a lot of times where I can't make a phone call or get on the internet, because that's, to me, the edge. It's those places where it's a lot harder to process information fast enough because you can't get on the cloud fast enough. So edge computing is making those decisions more locally on the devices, and then sharing it when is possible through the rest of the network.
Fair enough. What role do you think data plays? I mean, this is a Making Data Simple podcast, even though we go everywhere. But what role do you think data plays, and what should organizations be thinking about as it relates to their data?
Yeah, I mean, data is everything. IoT wouldn't be anything without data. It really is the sensors and the information that is being created by these things. That's the data and the power of IoT. So it's just, in my opinion, the same thing. Data is IoT, and of course, it's more that marrying of data with the processing and the insights. So using artificial intelligence and machine learning and the cognitive computing, right, to make that data interesting.
Well, the next question I was going to ask you is about what role does AI play, but I'll change that question a little bit, just in terms of, because you kind of mentioned an element of AI. What do you see as some of the big changes in IoT? You know, we just started out the new year in 2018 and beyond. I mean, now we've got IoT, we got artificial intelligence, we got blockchain, we have the edge. It seems like it's all coming together. If you were to predict anything, what would your prediction be over 2018 and beyond?
I mean, we're just getting started. It's so exciting to see where this is all taking us. I am personally excited about stuff like voice, and how voice and the interaction with individuals is going to take off. Being able to talk to our things in our computers without having to type it. I mean, a lot of people are slow typists. Some people are on text. I'm a pretty fast typer, but not everybody is. So just this ability to use your voice and to explain what it is you want the machine to do, and have results out of that. I think that we're going to see a lot of our things incorporate voice to be controlled or to do other interesting things. And that'll take into account a lot of the blockchain and edge computing, just because of the nature of voice.
Let me ask you a question. I mean, I get your point of IoT and cloud being siblings, but do you also see a scenario where IoT or edge, whatever you want, can be self-contained, where you have compute, storage, decisions on the edge, acting solely with the other IoT devices without the need of cloud? Or do you see always cloud being there to take that information back, do some learning, throwing it back, maybe even machine learning, and throw it back to the devices? Do you ever see it being self-contained, or do you see it always as a sibling that are connected?
There's definitely an aspect of it that is self-constrained. I know we had a use case within IBM where we were talking about helping a speedboat, right? And they were doing all this edge computing because they weren't able to go over the network quick enough to help make decisions for the driver of that speedboat, to how to change all the levers in the boat in order to win the race. But then after the race is over, being able to send that data to the cloud to then process and make hindsight kind of insights of how you could have done this differently, or the decisions that you made made this result. So I do agree that there's definitely an excitement about being able to do it just on the edge, but it's the sending back and the learning from those behaviors that is also interesting, and we can't get away with not doing the cloud as well.
A little bit later in the year, I connected with John Thomas for a conversation about machine learning. John works directly with clients every day on machine learning initiatives that have the potential to transform their organizations. I asked how he helps those teams set priorities and manage expectations.
Al, we take a very, very practical approach, right? So when I go in and talk to a client, what I say is, I'm not here to boil the ocean. I'm here to work on a very specific, tangible use case. And I'll make sure that that use case succeeds. So what we do, we ask for a few things. So one of the things we ask for is we want business involvement, business commitment. We don't want to just go talk to somebody who is playing around with tools and show him some tools and walk out of there. We want the business, the line of business to be involved. 2, we want the data guys to be involved. And 3, we want the data scientist team to be involved. So 3 different entities have to come together. The business, the IT/data owners, and 3 data scientists. And these are different entities who have to come together and own the problem and work with us collaboratively. And then when that happens, it becomes a successful 90-day engagement. Now up to 90 days, we can do 2-3 sprints, 60 days, 90 days. But at the end of it, it's a tangible set of assets that the business sees value in, and then they can scale.
As an extension of that question, do you ever get to a client and they don't have a data science team yet?
Yeah, so we do. As much as possible, we do a lot of prep work ahead of time to say, these are the roles we're expecting to be at the table. Usually we do a day-long workshop, going through the use case, taking it apart, understanding data sources and applications at play today, understanding the work that has been done, and so on. In the case of clients where data science teams don't exist at all, we have not. There is always somebody who claims to be a data science team in every enterprise that we have walked into.
But you said the key word, claims.
You usually get someone, but if the skills are really lacking, then the DSE team will obviously train them as we go through the engagement. In fact, I would say the actual algorithms are almost secondary. In order for, I'm not downplaying their importance, I'm just saying without these other pieces of the puzzle in place, no matter how good an algorithm you write and no matter how great a model you build, it is just going to stay as a model in someone's workbench. It will never see the light of day.
What is your most common use case? You mentioned a lot about use cases, or maybe an extension to that question is for the folks listening, what use case is almost a consistent area where almost any company in the industry can get value from?
Such an interesting question, Al, because it was not one we expected it would be. Our team has gotten involved in pretty much every industry, every type of use case, ranging from aerospace to banking. The one use case that keeps coming up again and again across industries is a call center use case. So the idea here is, can the business understand why a customer is calling into the call center? Can they understand what is in the customer's mind, read the customer's mind to some extent? Can they understand the intent in the conversation and change in intent as the conversation progresses so that you can reduce call handling time, so that you can reduce number of transfers? We started off this with one client in the banking industry, and then we found out the same exact use case pop up in healthcare, in a variety of different industries, and they all have the same pattern, understanding salient topics in a conversation and be able to respond to that in the most efficient way. Now, what's interesting is that in some of the cases, it started off as a call coming into a call center, but the same mechanism, whether it's a chatbot interacting with an end user, or if it is a combination of a virtual agent and a human agent interacting with an end user, they all follow the same kind of paradigm where you have to understand salient topics in a conversation and interaction, and even learn as the interaction progresses and be able to engage with the client in a very compelling way.
A big topic across the world of data is visualization. How do you use visualization to convey the insights of data, by example? We were thrilled to get Jillian Lellis on the podcast to talk about this. Jillian is a senior data analyst at Hoyt Cat, and I asked her how she sees visualization in her business and why it's so important.
We are blending science and art with the storytelling. Humans are meant to see things visually. If you go back to the caveman days, you see all of these drawings that they used to tell stories. So why should data be any different? If we have the ability to draw the user's eye to a specific piece of data that makes it quick and consumable, why wouldn't we do that? And one of my favorite examples to point out is just to show the importance of visualization. Have you heard of Anscombe's quartet?
I don't know that I have. Maybe I should have. Nope.
Okay, well, I highly recommend Googling it, because what it does is he was a statistician back in, I want to say, the 18 or 1900s, way before we were around. And he has 4 identical data sets. And when I say identical, I mean that all of their statistics are identical. So the means of Y, the means of X's, the variance of both Y's and X's, the correlations between X and Y, the linear regressions, and the coefficients are all equal. So if you looked at these tables of these 4 different data sets and you only looked at the summary statistics, you would think, okay, this is the same data. But when you graph it, it is completely different. Each one of those 4 data sets is a whole different line. And without that visualization, any user that would say, oh, well, they have the same mean, they have the same coefficient, they have all of the same stuff, so they must be the same, they must be telling the same story. But that's not actually true when you graph it out. And that's just one of my favorite examples of how visualization can help show the point that you're trying to make with data.
It's one thing to come in and say, here are the results. It's another thing, and what I find when it really works is when somebody comes in and says, here's where we missed our targets. Now, it's still based on fact. It's still based on the data. You're not trying to look in somebody's cookie jar unnecessarily. But, visualization with the right leader and influencer that can take that information and then really point out via visualization, the actual activity that caused the problem. That's where the magic happens. And I got to believe that you're doing both, bringing the data and then talking to the activity that you see causing the problem, which results in the corrective action.
Yeah, and it's very, very critical the way you present the data, right? So like you said, you can frame your conversation 2 different ways and it will be received completely differently, whichever way you frame it. And so when I present data to executives, I don't have any of my knowledge showing, right? I just say, here's what we're seeing. And then I start asking them questions. Which store do you think has the best performance this quarter? Is that higher or lower than last quarter? Where can we improve? Rather than saying, man, sales are really sucky right now. You know what I mean? Like it's all about your tone and all about how you present the data, because some people can tend to get very defensive, especially when we have this level of intimacy with the data. You have to walk a fine line between knowing the answer and pointing them in the direction to get the answer.
One of the smartest folks I know, and I get to work with, is Adam Storm, with a superhero name. He's a data architect focused on storage and fast data. I asked him to give us some context and talk about current challenges.
If you look 20, 30 years ago, data was a fairly simple problem to solve. There was only a couple of ways that you could store it, a couple of tools that you could use to store it, but your options were kind of limited as to how to store the data and how you can make it accessible. So we had, it was simple in some respects in that if you had a data problem, you knew who to turn to, but your options weren't as wide open as they are today. So now fast forward 20, 30 years, especially in the last 15 years with the rise of things like Hadoop and all of the open source technology that's out there, there's a whole number of ways that you can store your data. The problem is a whole bunch of those ways are not necessarily good ways to store data. And you see there are a lot of architectures being proposed in open source and in forward-thinking companies that may work for them at the scale they're working at, and because they want to leverage open source tooling and they have the staffing to do that. But they're setting up tremendously complex architectures which companies that don't have their resources aren't able to do. So I think that you and I are both trying to do the same thing, which is to take this massively increasing amount of data and make it simpler to manage. So to take the complexity that's come into the industry in the last 15 years and really simplify it at an enterprise scale.
So let me ask you this. Why, when I ask you what you want to discuss, you go immediately into fast data?
I think that fast data presents its own interesting challenges. Obviously, the data is coming in extremely quickly, so much so that there are streaming technologies out there today. That's the predominant way of handling fast data. And what they do is they analyze it in small sections and then just throw it away because they can't persist it fast enough. So there's the challenges of bringing the data in quickly, but also as you're accumulating all this data very quickly, you end up accumulating a huge amount of it very quickly. And so you need to handle the storage, store it in an effective way, but also in a way that you can make use of it. Having data on disk isn't valuable. Deriving insights from that data is the value. Businesses need to derive insights faster and faster today to get value out of their data.
So when you and I have talked about this before, you have mentioned various solution vehicles for this problem, like Lambda architecture, Kappa architecture, modified Lambda architecture. It seems like there's no perfect solution. And I know we can get into the bowels quickly with some of those, maybe those three areas of discussion, but at least at a high level, can you give your thoughts? I mean, is it as confusing as it sounds with all these different architectures to solve the same problem?
I think it is as confusing as it sounds. Okay, let's take a step back. So if you look 15 years ago, there was this, some might call it a renaissance of open source tooling that ended up in the hands of data professionals. So there was Hadoop came out of Yahoo, Facebook open sourced Cassandra. There was a whole bunch of LinkedIn open sourced Kafka. There's a whole bunch of open source tooling that's available now. And a lot of people are seeing this and saying we can cobble together a solution with all of these components, which I think works for a lot of companies, especially if you're willing to put in the energy. But it's tremendously complicated for a shop that doesn't want to devote a huge percentage of its resources to bare bones IT and data management. It's difficult for them to take the same approach. And I think one of the big problems is that if you go on YouTube or you go on SlideShare and look at all of these presentations, these companies like Google and Facebook and Netflix and Uber have huge IT departments that are putting together infrastructure to store all of this data. If your company doesn't have the resources or the appetite to do that, there has to be a better solution. There needs to be a simpler way to store these kinds of large data sets.
Well, to your point, I mean, the thing that's really interesting to me is I'm talking to many clients about cost savings. And then in some of these architectures that you mentioned, I turn away and then look back and they've got small armies that they're spending to stand up these architectures. And I'm questioning now, what was your original goal again?
I'm seeing that a lot too. Like I talk to customers, and especially over the last 5 years, it seems like there are a lot of larger customers who, when I say large, I mean large by market cap. And they think, well, we can just roll our own data solution, leverage open source, build it on Hadoop, bring in all of the best of breeds of like the Cassandras and so on, and we'll roll our own architecture. And 2 or 3 years after they've gone down this path and have not put anything into production yet, we end up talking to them and they say, this was the wrong approach. We don't have the staffing, resources, or the appetite to do all this. And we want an enterprise software company to deliver a solution for us.
Let's close with a look at machine learning. IBM is very lucky to have Jean Francois Puget as a distinguished engineer and an expert on machine learning and optimization. I asked him to talk about the difference between AI and deep learning.
So I agree it's confusing. So it's very simple. Deep learning is a set of technologies called neural networks that is good for image recognition, understanding speech, and or videos, understanding what's in videos. So processing unstructured data and learn from it. So that's deep learning. Deep learning is part of machine learning. There are other forms of machine learning for structured data. And then, so deep learning is a form of machine learning, and machine learning is one of the capabilities of AI. Artificial intelligence includes machine learning. It includes also reasoning. The Deep Blue playing chess is AI, or AlphaGo playing Go is AI as well. It's not just learning. So AI includes reasoning, includes natural language processing, and it includes machine learning.
So you're suggesting deep learning doesn't include the reasoning part?
No, deep learning is just about processing. Deep learning is about replicating the 5 human sense: vision, hearing. Well, it's mostly vision and hearing, but what's on as a taste, what's on shape, for instance. So it's based on deep learning as well. So deep learning is about replicating human ability to process sensor input. The eye is a sensor, the ear is a sensor. So it's an important piece of intelligence, but it's not all of it.
And just as another taxonomy, neural nets being nodes that are interconnected that just model the human brain?
No, so deep learning and neural networks is the same. It started that way in the 60s with people trying to replicate, to simulate in computers how the brain works. So they started with neurons and connection between neurons. But it has evolved in a way that now this analogy is no longer true. What we call it neural networks, but they are really, actually, you've heard also tensor, like in TensorFlow, or matrix multiplication. And deep learning is really a bunch of matrix multiplications. It has nothing to do with how the brain operates today. People are still using the analogy to get the buzz and headlines, but no.
It's different. That's good information.
It has some people are still working in neuroscience, trying to model the human brain, but it's different from deep learning.
So, extending that a little bit, you referenced Deep Blue.
Yes.
Certainly we have Watson. Arthur Samuel was one of the first out there in IBM, I've said before, and he created Checkers, which was...
It was the first machine learning program ever.
Exactly. But I guess the question is to extend that further. I know IBM is doing a ton more as it relates to neural nets, deep learning, etc. I don't know if we need to do a better job explaining that at times, or do you think we're doing well in that? And if you could, at least talk to some of those technologies that are shaping the market.
So we have an issue, and not just us, all the vendors of machine learning technology. There is hype, and there is what people really need. Hype is on deep learning to recognize cats on YouTube videos.
I've seen enough cat recognition, by the way. This is crazy stuff. Anyway.
Yeah, so it's fun. Everybody can relate to it. I say cats, but it can be anything of interest. It has some value, and in some, for instance, it certainly has some value. But our customer, they are enterprise, they process structured data. We host it for them, we manage it, and they can learn from it. And the technology they need to learn from it is not deep learning. It's other machine learning technologies. Problem is those technologies don't make headlines. So we have to educate people on, yes, TensorFlow and deep learning is great, but do you really have an image recognition problem or something else? And if it's something else, then you may need something different than deep learning.
Where do you think ML, AI is doing well? Where do you think, you got to be like any technologist frustrated in some areas because it's not progressing.
So I think the main, for people working as data scientists, that the job market is crazy. There is a lack of data scientists and people are fighting for talent. And one reason is the current technology, as good as open source is, it's very time consuming. The data scientist to build a model needs to do a lot of trial and errors. It's consuming a lot of time. So one of the priorities we have this year is to work on automation, and we're not the only team, so that people can perform the same quality of machine learning model by spending much less time. So we're working on automating the work of data scientists, and that's a trend in the market. And it may be that in 10 years, we won't need data scientists anymore. I doubt it, but I rather say that the job of the data scientist will be more productive.
Yeah.
They will concentrate on where they add value and less on tasks that we automate for them.
There you have it, some great material from 5 of our best episodes. Thanks for listening, and thanks for making 2018 a great year for the podcast. We appreciate your attention, we appreciate your engagement, and we're looking forward to bringing you more great guests and great conversations in 2019.
Thanks for listening to the Making Data Simple podcast, where we make data fun. Be sure to visit IBMBigDataHub.com/podcasts to access the show notes and uncover even more great episodes. Remember, the views expressed here are those of the host and its guests and do not necessarily represent the views of IBM. Until next time, over and out.